Welcome to Python 2. It's nice to have everyone here. We've got Joanne, I know Joanne, and Cliff and Rob. I think this is our first class together, right?
Yes, for me it is.
Well, welcome. It's nice to have you.
Thanks.
We have a pretty good chunk of folks coming, and one of the best ways to start later and later is to wait for people to come. So I want to propose an agenda for tonight of contextualizing Python 2 in data analytics, give you a chance to ask some questions about where this course fits and how it fits into our vision of a major data project, review textbook, development environment, where to code, that kind of thing. Then do our class keeping, get set up with names and identifiers. Then we'll jump into some, I've got a Python review exercise, so we'll see where people's Python seems to be sitting. And then we'll start our first project, which is the icon project. That should be quite cool. So, good, Rachel. Hey, Rachel. Nice to see you. And they're dropping in. Hey, Steve. Good to see y'all. So Python 2 is the second in our series of Python classes. We have schemed this term. Our major project, me and Coral and Rebecca, is revamping almost all of our data analytics courses based on our first graduating cohort. So we had our first 4 graduates in the spring with the poor digital COVID ceremony of PowerPoint. So in the spirit of trying to be responsive to our advisory board, I want to give you a couple of updates, most generally, and then if you want to know more, I can tell you more. So the big debate has been Python versus R, which are the two major languages for data analytics that programs across the country are focusing on. And we made the decision to make a Python 1 and Python 2 sequence at the core of data analytics for a couple of reasons. We anticipated a chunk of folks coming in who were not experienced with any programming language, and it burned our hearts to think of starting someone programming in R, which is it's certainly not it's not a Turing complete programming language if you want to be specific. It's a data scripting language that is kind of exclusive to the data domain, whereas Python is a full multi-purpose language. And so we decided to go with Python for that reason. With the evolution of a couple of years, we first ran our R course as a final term course, and that gave our upper level students a chance to try a new language, so they had both under their belt. What we were hearing from industry is, we kind of expect you to be able to work in both, since almost every data analyst you'll interact with is working in either, so they like you to be multi-purpose. So we also have plans to create an R2 in that spirit of giving students as much exposure to the two languages as we can. So in other words, we'd say we want eventually the Python 2 will become an OR with the R, and so we have everyone go through Python 1 to get a basis in programming, and then they can choose if they want to jump over to the R track or stay on the Python 2 track. Right now, you're all on the Python 2 track, so welcome to Python 2. Some other notes that just as a follow-up, since you've been around for a while, some of you, we are moving forward with the data 201. I think I talked to some of you that we scrapped the 201 because it was too heavy and there was too much crammed in there. And so we meet every Friday to rewrite the curriculum. And so what we've done is we've taken the data 201 and we've split it off into 2 courses. The databases course, so databases for data analytics specifically, and we're willing to take on the CIT department with that. And we have an unusual relationship with our parent department in that I think they would like us to become our own department, but we're not. And so technically we have some overlapping course content, but we don't think it's all that similar. We instead of focusing on database administration, we want to focus more on what are the ways to read in big batches of information. How do you how do you create a database so that it is the most flexible for analytic tools rather than say a logistics system where you're doing a whole bunch of read and writes to the database in which you're maximizing the storage and manipulation inside the database, whereas an analyst is going to try to get stuff out and ship it to another program. And then the other course we're splitting that into is GIS, or in other words, mapping. And so our plan is to make the GIS course an either or with the DAT-203, which is more general visualization. So for, I think it's the case that most of you would be in a position to take the databases and then either one of these next term. Is that kind of where people are thinking for your trajectory? Maybe, who knows? The head bobbing. Well, that's how we're planning it, and we're open to feedback insofar as you have it for us. So that's data analytics. We're in full revision mode. So again, all the feedback you can give us is helpful. Okay, questions on that? Great, it's nice seeing so many familiar faces back on Zoom, even in COVID land. Okay, so Python 2 is a fun class because we get to kind of dance around some of the most exciting analytics topics, and our plan is to do probably, well, let's just jump in and look at the actual sequence. Our plan is to do about 6 mini projects that expose you to what we have, what Python can do analytics-wise. Hold on, I gotta move this around. Where are we? No, I want to share the other desktop. I want to share desktop 1. Okay, so let's, if you're new to my course, we'll always use technologyrediscovery.net as our homepage. There's no Blackboard. And I had to turn on my Blackboard course for my online async students, and it reminded me why I don't use Blackboard. And when you first get a class from Blackboard, it's turned off and no one can see it. And you're, well, how do I turn it on? And you look for some sort of on button. It says like this course is not available. And when you hunt down the help, you have to go to customize, and then preferences, and then the 4th item down as a little checkbox of make available to students. Since when is customizing a class? Turning on the class apparently is customizing it. So that's an anecdote of why I don't use Blackboard. It would be, to do 6 courses at this level, I would not survive. So here we are on technologyrediscovery.net. We have our new picture for the term. Jump down to Python 2. We'll spend the first chunk of tonight reviewing the syllabus and the schedule. So if you want to pop those open. So what are we going to do in the class? And here's our schedule. So we want to bring everyone together on a foundation of essential data structures. Lists, tuples, and dictionaries are the workhorses of Python. So the first project and the next, this week and next week will be internalizing or re-internalizing as much about the essential manipulation as we can. It would be fair to say that almost all of what we're going to do in terms of projects is getting data from different kinds of sources, flat files, APIs, web scraping, databases, and they're almost always going to go through a dictionary or a list, or more commonly, a nested composite structure, data structures that we manipulate in Python, and then we ship out either to a whole nother program or we visualize it somehow. So that's the highest level. So to build that foundation, we'll review dictionaries. JSON is the native data encoding language for JavaScript and the internet in general, and it also is built into Python. So we will get a chance to use the JSON read and write tools frequently throughout the term. We'll do I have a feeling that we'll be able to compress week 2 and 3 into one, and then probably devote an entire evening to Git. Let's do a little raise hand thing for a second. How many of you would consider Git a good friend? How many of you would say you're friends with Git? Meaning pushing, pulling, commits. Where's our hands? Participants. How many Git friends out there? Oh, Git doesn't have a lot of friends. Okay, so the gateway tool for collaborating with each other will be Git version control. And so you'll see on week 3, I have links to the Git book, which you're going to want to dig into as soon as possible. The Git book is free. You can download it as a huge PDF right there, and it's also an HTML version. So Git is one of those tools that has taken me years, actually, to become friends with, and that only happened after a number of almost breakups. I had my repository for my whole database project. I woke up one morning and I couldn't even run a Git status. It said corrupt database. It said I can't tell you anything, and it took a month and probably 50 or 60 hours to remap 400 some commits on top of a new base. I share that story not as a fear story, but only as the reality that it's a complicated tool, but is in fact probably the only tool that has the chops for collaborative code-based work that people are using today. So having that as a cornerstone of Python 2 is something that Coral and I have decided is important. So I have the Git kind of, I realized that Git was more important than I was considering it last term, and so Git got kind of sprayed all over the place. So the exciting part will start when we can grab data from someone else's database, and that will be done first through an API, an application programming interface, that will give you a chance to retrieve structured data from another source and manipulate it. And then we move into web scraping, which would involve getting data from a web page designed for browser viewing, but instead we're going to ingest it with a Python library called Beautiful Soup. We will make soup out of it, and then we can extract what we want. And so the web scraping project will be the second of our major mini projects. And throughout this process, I'll be encouraging you to manage your own coding through Git and keeping a commit history of your work in Python with Git. So just remember that will come our way. We'll pause in the middle of the term, and I will invite you to choose a topic that is not necessarily large enough for an entire course session, but can be a little mini burst lesson. And so you'll each get a chance to pick a Python related topic and share it with one another in a little group breakout. So that'll happen in the middle. Those topics include comprehensions, regular expressions, some argparse for dealing with inputs to programs. And if you have a particular specialty that you feel like you could share with one another, maybe you have a specialty in network stuff or engineering Python, those kinds of things, we can sign you up for a topic. Then we'll take a dive into how Python can manipulate your file system. And I'll show you how in about 12 characters and an enter key, you could wipe out the entirety of your operating system with Python if you're not careful, which will be a testament to the power of this programming language. If your Python script has the permissions, it can do almost anything you could imagine with the file system. Complete manipulation. You could even build whole operating systems worth of file structures with Python. we'll close out with connecting Python to databases using Sqlite and Postgres if you're ambitious. And most likely this will get moved up so that we have a couple of weeks to do the project. With COVID, things slowed down a bit, and so I'll probably end up compressing up on the schedule a little bit. Whew. Okay, how's that sound? Does that seem like stuff you want to do?
Yeah.
Great, great. And once again, for those of you that haven't worked with me, I certainly hope you'll share with me if we're not meeting your learning goals, you speak up as soon as possible so we can adjust. The best thing is to not get frustrated and wait and complain at the end, but bring it up in the middle. So that's what we do in the class. Let's jump over to textbook. I should be the case that this was your required book from Python 1, the Untitled book. With a great deal of consternation, we chose this book. Both Coral and I were aghast that Pearson was yet again going to fleece us, but we increasingly found that this book contains just about everything for both Python 1 and Python 2, and our general thinking from Coral was that Python 1 would bring you up approximately to the beginning of chapter 9. So Coral mentioned that you had a little bit of experience with files, but probably at the most rudimentary level, and and Professor Sunas and I no longer communicate, so I'm not sure where you left off there. To the extent that you feel a little shaky with Python, I think this first project will give you a chance to review some of the basics. So my plan is to integrate the book more than I did last term. And one of the nice things is it'll give us a chance to dig into some more interesting libraries that we may not have touched on in Python 2 before, particularly machine learning. And we can even link up to Watson, IBM supercomputer, and it has some tutorials in there for things like that. I also particularly like the Untitled because the first 7 chapters of Python Review are meaty, and they're meaty, but the examples are small enough that you can kind of soak stuff back up really fast. Can you do a raise of hands for those of you that have this book? You've got it, exists with you. Your digital hand, by the way, is in your participant box. Oh, good. This is not required. I would never make someone buy a $100 book. You could certainly do without it, but I use it quite a bit these days as my reference, and I like learning out of books. This is listed in the syllabus if you don't yet have it. To the extent that you can get a used copy, or I would never recommend a digital copy of a book, but you could go that way if you're comfy with it. Questions on book? Book. All right. So development environment. Let's, if you can grab your chat window and chat out to everybody. Please chat out chat out your preferred dev environment for Python. So I want to get a sense for what you're comfortable with. Some of you may have worked on Spider. Some of you may be in just a text editor like Atom. Some of you may be in Jupyter Notebooks. Kind of curious where folks are. Okay, a lot of good spidering. I warm up to Spider even more and more. I have a student that worked with my project, and we've got the whole database wired up to Spider, so you can actually get code completion of database tables in Spider if you wire it up right. So
Professor Sonis had us download Anaconda, so that's why
Great.
we all use Spider.
Great. And Anaconda is something I would strongly recommend. I'll be demoing mostly out of Jupyter Notebook, but I should fire up Spider so that I can have that context too. Okay. You can use whatever you want for the class. I'm infinitely flexible in terms of how you run your Python. There's a lot of ways to run There are many ways to light Europe, or choose your phrase.
In terms of the industry, mostly through Jupyter Notebooks, or
the data analysts we talk to share a lot in notebooks. I'd say it's probably 3/4 notebooks and the rest just straight scripts that are sent as files.
Gotcha.
So notebooks is making a lot more facilities for going to and from straight Python. Even the last couple of years, it's gotten better.
Hey, Eric, quick question. We've all used Spider here because we're in Python 1, but and that just kind of has like the execution window next to your script window that you're making. Jupyter Notebooks is able to break down when you screw something up like line by line, right? How does that work?
You put the code in individual cells, and you can run those cells individually in an ongoing Python interpreter environment. So
okay. You're able to check what the return of each thing is, and you can make sure it's what you want it to be. Yep.
Okay. From an analytics standpoint, people like Jupyter Notebook because you're often thinking about the data life cycle in distinct chunks. So you can read stuff in from the database, see its output, then you usually process it in your script.
Yeah.
And so it's nice for kind of phasing through the individual steps in testing.
Okay.
So you might poke around in that. It also is nicely integrated with the shell, so you can just run shell commands if you're in Linux or OS X.
And can we just download it for free online or something, or what?
Yep. The best way to get it is in the Anaconda package. It's part of Anaconda.
Okay.
You've got Spider and you selected the full package. You also have Jupyter Notebook.
Okay.
It's already in there. Cool. Very fun. I get really jazzed about Python.
When you say it's in the shell, what does that mean?
So shell would give you a chance. The shell is your window to talk directly to the operating system. So here's my the shell lets me see what's going on in there and run commands directly talking to the OS system.
Okay, so that's the same as like, well, when I said the execution window, that's like the same, that's what it's called.
No, the execution window would be basically this interactive Python. It will give you whatever comes out of interactive Python. The shell is one step back and is directly talking to the operating system on which you might put a Python interpreter.
Okay.
Yep.
So when you say Python script, that's what you're saying when you say it again?
So the output window in Spider is a view of anything spit out by the Python interpreter.
Yeah.
The shell is, or a operating system shell is the platform on which any program could run, including a Python interpreter or any other piece of software. We would say you could run those, you can issue those commands, and then those applications run within that shell, which is an operating system contained environment. So
okay, thank you.
And what I should also mention now that you're in our upper level classes, Jill, welcome.
Hi, how are you? Hi, everyone.
Good to see you. I like your background. If you haven't considered dual booting to Linux, or you don't run on a Mac, that should be, you should prepare for that moment when you're ready to do that. When I first started doing Linux, we had to schlep our whole computers into a room where other Linux gurus would come in because there was no internet. And so if you ran into problems installing, you wanted all these people around to help you. Now it's so good that you can put on a thumb disk and you don't even have to touch your hard drive. You could run it all off the thumb disk as a live boot, and run it completely contained in there. It's a good way to start with Linux. And then when you're ready, you can partition the hard drive, and when your computer turns on, it'll ask you, do you want Windows or do you want Linux? And
how
I've
do you
never had someone lose a drive from doing that.
So like you put the whole operating system of Linux on the flash drive, and you just plug it in. I mean, if you're in Windows and you plug it in, it's not like you can just switch it over. You have to reboot the computer.
Yeah, and if you're in Windows, Bill decided in Windows 10 to make shutdown not actually turn your computer off. So the trick is, the hardest thing I found about loading Linux is turning Windows off, because the standard off is actually just writing Windows to memory and not shutting your computer down.
Shut off.
You have to hold down Shift. It's strange moments while shutting Windows down to get a complete shutdown, and even that doesn't always work. So
That's
Windows
great.
tries hard to make it difficult to use. Although you can run Linux inside Windows now. They came out with Windows Subsystem for Linux, and I begrudgingly tell you that I've seen quite phenomenal results. I would never
So what were the benefits of using Linux over like Windows?
particularly the shell is being able to interact with programs and files via the command line, which is probably the handiest thing in a data situation, because you're almost always weaving together multiple tools.
Okay.
And most of those tools, Anaconda, Python, Postgres, they were all written in Linux. They were written for Linux environments. They were written by people on Linux. And so configuring them in Linux is significantly easier than Windows.
Okay.
Not impossible, but it's the native world of almost all data processing. Almost all of Google's suite of tools was written on Linux computers for Linux users. So
Do you have like like a tutorial or guide or like a setup type thing to where we can do this like one of these times outside of class?
I'll need to build that. That'll be a little bit later. I want to start with Git, and then you can go to Linux probably a little bit later.
Okay, thank you.
Yep. Okay, where were we? Class keeping. So we can do this pretty fast since a lot of you kind of know my approach. For those of you that are new, I'm going to invite you to take some time and review my grading approach, which is based on student grade proposals. And maybe since most of us have worked this system before, you could ask them for some feedback. So at the top of the technology discovery, point-free grading will give you an overview of how this works. The simple answer is, at midterms and final, I'll ask you to propose a letter grade, either A, B, C, D, or F, on a 3x5 card, and justify why you think that's a fair grade. And the justifications should be making note of work that you have completed. The grade proposals are the time in which intention to do work. This is not the place to state intention to do work, but rather what could you share if someone challenged you on your justification. So we'll continue that process this term. It'll be digital like we did at the end of last term, and I think that's been working pretty well. Questions, concerns there? All right. Next thing is naming. So I think, Joanne, you were in my Viz, so we did this together. Steve, were you in Viz too, I think? Did I get that right?
Yeah, I was.
Great. So we're going to redo the naming process. So if we jump down here to DAT129, I put it in our schedule. The naming triumvirate guide. So for those of you that are just coming to this term or just joining my classes, my default position in my course has been to share our work publicly, and part of that is because I've decided to share all of my course materials publicly, and part of those materials are based on building student projects that interleave with one another, and all sorts of symbiotic things come when people can share the work that they've made. And so to make this possible and preserve personally identifying information, I'm going to ask you to choose kind of your official public name. For most of you, that'll just be your first name that you can use when logging in, when naming assignments. You should never have to use your last name in my course, except for this very moment when you fill out this Google form, which is encrypted, and the spreadsheet will just stay with me. And then I'm going to ask you to come up with a code name, a secret name. And we'll use that tonight on our first Python review quiz. So this is your chance to be as stealthy as you want. You can use your code name any time you want, but no one will know that it's you. So if you want to build relationships with people, it's helpful to use a public identifier so that you have an identity that follows you beyond your code name. So what I'm going to ask you to do is just register those 3 names with me by clicking on the name registration form link, and click Python2, my official name, Eric Christopher Darso, my public identifier, my nickname is Edie, and my stealthy code name, no one shall know. So if you could take a minute and fill out this form, that would be great. Let's take 3 minutes. Is anyone lost?
I kind of am because I was looking for, I'm not able to touch anything on my portal. It doesn't seem like to actually get into, is it in Blackboard?
It's just on my website, Technology Rediscovery. No black.
To read the discovery. Oh, okay.
What I'm going to do is I will, if you look at the chat window, I'll chat out the form link.
For your secret, super secret code name, does it, is there any requirements? Does it have uppercase, lowercase,
Be
crazy,
anything
like?
that's unique and I guess publicly appropriate. So the way that I'm managing classes now is I'm going to make a little note card for everybody, and so on there I'll stamp your attendance and write your secret code name and notes about your projects and discussions that we have. I've now got over 100 and some students, and it's going to be a beast of a semester. So I'm trying to keep my life organized. Did that form open up for you, Jill?
Yeah.
Great. Good.
Okay, so I'm in the 129, the programming. Where is it at under that?
If you click the schedule, there's the first link there.
Yeah.
And then the third link down under session links is called name registration form.
Oh, okay.
Oh, good. Look, I even recorded my Git lecture. Whoa. That's great. Okay. That's really great. Take about 1 more minute on that. I'm going to just update my to-do here. Okay, I've got 7 submissions. 8. Wow, that's cool. I didn't know the response is auto-updated. That's great. Google, their Google Docs, that's a marvel of technology. Okay. Am I leaving anyone behind? I've got 2 more folks still doing it. Rachel, Joanne, Robert, Chelsea, Joe. Who am I missing? Someone signed in twice? Oh, I am. I'm signed in. Okay, I'll sort through that in just a second. So, are you ready? Let's see what you remember about Python. So I'm gonna try more of these to, by these I mean Socrative quizzes together, so that we can, I can address gaps in understanding on the spot. So let me share my screen again. Okay, so on our homepage, and I'll chat this out, is a link to the Socrative student login. And let me fire this up. Where are you, Socrative? Okay, there you are. Launch quiz, Pi fundamentals. Teacher paste. So this is where you're going to enter your code name, because I want to be able to use these, the reports and stuff that I get out of Socrative. They don't all scrub the names, and so I just don't want to be saving stuff that has your first name on it. So that's why I'm asking you to use your code name, for the sake of minding the privacy rules that are in place for good reason. Okay, so now that I've launched my quiz on my end, you're going to drop in here and say, join the Socrative room. So it's down here under cross-course resources, Socrative student login. I'm going to copy and chat this out. You're going to enter the room name Darso. Oop, that's not the right one. Don't click that one again. I don't know why that didn't work.
What's this place called?
It's called Socrative. Oh, it did go. It just didn't show me. So the link is in the chat. And this is a real-time quiz program that allows us to see the results from the group and talk about them as we go. So I'm just trying different things to allow us to be a bit more interactive than just one-way stuff. So once you sign in, room name Darso, the first question should be up there. I see 3 of you.
Put in our real name or
Your code name, your secret name. That way I don't want anyone to feel, I don't want no public shaming. We're all at different places in our learning, and I want to be able to talk about right and wrong without anyone feeling attacked. That's not a good thing for learning. So I'll kind of walk through some of these together, and we'll see how it goes. So I was known, when I taught high school, I taught economics. I was known for writing quizzes that tested students hated, because I always had A, B, C, D, and A, B, and C, and D, and all of the above and none of the above. And they said, why can't you just write a normal multiple choice question? I said, because they're too easy to game. So this is a select all that are correct about Python. Let's see what you remember or know. Python is interpreted. Python is compiled. Python is object-oriented.
What's the difference between interpreted and compiled?
We'll talk about that as soon as we look at the, how do we do?
Okay.
I want to see what's in you first.
No spoilers.
No, not yet, not yet. Python scripts run faster than programs written in older languages, like C. Python is a so-called strongly typed language. Python is a so-called weakly typed language. "15 seconds. And if I leave you behind on a question, don't sweat it. Remember, this is not a point-based course. So I'm always trying to negotiate being too slow and making sure everyone's included. So last one coming in. Someone is not logged in. Is everyone doing okay with getting in here?
Yeah, I'm in.
Okay, I still only have, is anyone signed in twice from 2 different systems? Rob, Chelsea, 1. Okay. Wait on last question, last person.
I'm not there yet. I can't find the link.
The link is in the chat box. And you'll enter the room name Darso. So D-A-R-S-O-W. We'll catch you on the next question. Okay. So we're kind of all over the board. So you should be able to see on my screen the results pop up. So
So we submit. Go ahead and submit it.
yep, submit the questions will go one at a time as I move them through. There you go. Great. And Paula, did you find it? Did you make it in?
Yes, I think.
Okay.
I'm in.
Great. And okay, so difference between interpreted and compiled. Python is an interpreted language, most notably, and is not compiled. So if we draw a quick diagram, and let's finish reviewing, then we'll draw a diagram. Object-oriented, 28%. Oh, okay. So everything in Python is an object. Even functions in Python are objects that move around and you can reference to them. You can put functions in lists. You can have the value of your dictionaries can be a function, an entire function. Every variable, every function, every module, every output is an object. Good. I saw it.
It wasn't object-oriented.
Pardon?
What would it be like if it wasn't object-oriented?
If it wasn't object-oriented, there would not be object name and then dot function or method. So there would be a lot more individual function calls where you have to call a function and the functions give you back something and you have to hold on to that thing. It looks a lot like C, which is not object-oriented. So there's a lot more, because things aren't grouped nicely into an object, the ability for you to move around large chunks of information is more limited. So you end up writing a bunch of code for exposing pieces of information to other chunks of code that in object-oriented coding, you just reference the object and everything in it becomes available somewhere else.
Got it.
And so let's think for a quick moment about computers. I have a computer sitting around here. Okay, here's a motherboard. So when we talk about a programming language, we are talking about, so here's a processor. I'm going to turn that upside down so we can see how pretty it is. When we say I have RAM too somewhere. Where's the RAM? Those little RAM sticks, if you don't keep a finger on them, they just run right off. RAM. RAM. RAM, this is your big moment. How can it be? How can we talk about RAM with no RAM? Okay, They got dumped upside down. Don't worry. Okay. So here's a stick of memory. This is DDR3 memory. So when we talk about software, we're talking about the set of instructions for manipulating data in the processor. Programs run, they get stored in the RAM, and those instructions are interpreted by the operating system and passed into the processor, who processes them or follows the assembly instructions that were given, and then that information gets saved back in the RAM. And so we have all of the software that we'll be working with lives in memory, and if we want information to persist past the time that we shut the computer down, we have to run code that transfers data from RAM or working memory over to non-volatile memory, a hard drive of any kind, a tape drive, if you will. So that's at the base of our computer, is a processor that can carry out simple instructions, and RAM to hold the outputs and the inputs of that. So if we think about a computer like a stack, at the bottom of our stack we have the hardware architecture, and most importantly we mean RAM, temporary memory, and CPU, our processor. And then hooked up to that hardware could be a permanent hard disk drive, network adapter. Those are all accessory pieces of hardware. And how do we get access to any of those? What's our layer of software that knows specifically how to talk to the hardware?
Operating system.
Yeah, so we've got our operating system here, and operating systems, most notably, are what provide the application software a unified interface for common operations. So operating system says, hey, application software, if you want a file, I will provide you a operation. In operating systems, there would be a function. I'll provide you a function like get file. And if an application wants to get a file, you ask the operating system, hey, I need this file from drive R. And I don't care how you get it. I don't care whether the drive is magnetic or optical or little puffs of smoke in little bins. I just want you to find it and get it up to me. So application software relies on the operating system knowing how to talk with the hardware. And one of the pieces of application software that we focus on in this class is the Python interpreter, which is responsible for taking in Python statements and making the appropriate requests to the operating system for processing and management of our memory. Now, one of the ways that Python can be so convenient is Python lets you say something like, we can say, we can use the open command, and we can say, I want to open a file with read-only access, and that file's name is names.txt. So Python lets us say something extremely simple, and the interpreter in Python is extremely powerful in that it has inside of it a whole bunch of modules that you can invoke with very simple commands. And so the Python interpreter takes one line at a time, or one iteration statement at a time, and figures out how to manipulate the objects that it stores in memory. So one way to think about RAM, if we blow RAM up, what the interpreter is doing for us is part of the RAM would be called the object heap. And so when you open a file and you want to read data from it, the Python interpreter says, okay, operating system, we need this file. And it does a whole bunch of communicating to package a reference to that file in a file object and stores it on the heap and lets you access that object with a variable reference. So you often, probably from Python 1, would do something like f equals open our names.txt, in which case f is a variable that allows us to access an object on the memory heap. So we would say that in Python, variables, all of the variables that we work with in our scripts are containers for holding a reference to an object on the heap. The analogy is a remote. I happen to have a remote handy. So a remote allows you to access a larger piece of electronic equipment. That's exactly what a variable in Python is, all of them, in fact, because everything is an object on the heap to the Python interpreter. And so those variables are remote, they're access pathways onto the object. So when we say interpreted, the Python interpreter, we would say, is once the Python interpreter is running, it maintains the state of its objects on the heap in between individual statements that we give it, meaning it is happy to sit there and be an interpreter and wait for me to tell it to do one next thing and then one next thing. So an interpreted language is like you can have a conversation with that interpreter, the end of which is not known at the beginning. You can say hello, and then it has to decide what to do, and then it says something back. That's a distinctly different programming model than, say, C++, which is a compiled language, and it's a compiled low-level language. So interestingly, with C++, if we draw, we do a comparison. So here's our great divide, but operating system's going to stay over here. So this is interpreted high-level language. So in C++, we have a file of C++ source, and we feed it into a compiler all at once, and that compiler spits out a self-contained, a whole program, which we might think of as something that we can inject directly into the operating system for executing commands to hardware. So we have to have everything bundled, and we give it to the compiler, and it ships out in one package all of the required instructions for an entire program. There's no in-between editing. There's no in-between interpreter that's keeping track of which objects you've put on the heap and giving you feedback if they're not in good shape. What the compiler will allow you to do is access these hardware resources directly. And so the answer to the letter D, Python scripts run faster than programs written in older language such as C. The reason that this is false, so 12% of you thought Python scripts were faster, is because C is like C++ in that it is speaking more directly to the hardware, and that it's faster because we don't have to wait for a whole in-between bunch of code, the interpreter code, to interpret what we say and then figure out what to say to the operating system. C and C++ are telling the operating system what to do directly. And so what we'll find when we start doing data processing is almost all of the major data processing libraries, most notably NumPy, they're all written in C. And so what they've given us is they've given us a set of Python objects that know how to talk with compiled C code that's already been bundled, and you load it in that's specific to your hardware. And so you can do super fast crunching of data, and then it just gives the results back to your interpreter, which then can display it in a Python friendly way. So it's important.
Can you compile a Python language at all?
You can pre-compile modules in Python for faster use. But we won't be.
In an executable format, it'll be a self-executing file.
I don't believe it will be self-executing, but what you're doing is there's a bunch of optimization that the interpreter will do on the fly that compiled Python will have done once, and then what it writes out is basically its own internal output. If you think about it, it has you can think of it like a pre-compiler that issues kind of the authentic instructions A, B, C, and those can be pre-arranged so they run faster. So that's what a pre-compiled Python module is.
So that you're going to have an interpreter on a computer to run a Python script or a Python program.
Yep. As far as I know, I could be wrong on that, but I haven't seen it.
Well, I've asked other people too, and they said the same thing. I've never seen an executable Python program.
Yeah, and I wouldn't quite know what that would look like. So kind of an interesting thing. So we have a trade-off. In other words, we have Python that allows us to do a whole bunch of stuff in very short amount of code, but there's an overhead cost in that the interpreter is doing more of the work for us on the fly, and that requires resources, processing, and memory. So for people to say, oh, Python is replacing these lower level languages that talk directly to the hardware through the operating system, that's not accurate. We have an ecosystem of jobs and tools, and we're almost always building chains out of a variety of tools. So Python it's not going to be the thing that takes over every other language, but boy, it's amazingly concise. All right, next question. This is a let me learn a little bit more about you question. Which of the following describes your comfort level with Python? I'm fluent in Python. I can compose scripts with minimal or zero consultation of external resources. My Python is strong. I can manipulate its key features, but I still rely on documentation from time to time. Maybe you're shaky, or maybe you're starting from scratch.
Hello?
Hello, I just stepped out to turn down my fan.
Hello, I'm having issues. Mine was loading. I'm trying to log in again.
Okay.
It's not letting me log in.
To the Sqlite?
Yes.
What does it say?
It looks like it has to do with the casing. It's coming up all in capital. I want it to be in lowercase. I don't know why it's doing that.
When you're typing in Darso, when you're typing in my name?
No. I'm talking about my my student ID that I have to put in to get access to the secretive.
Oh, you don't have to put your student ID in. You just type in my last name.
Okay.
Yep. And it will come up in all caps when you type in my last name. But you shouldn't ever have to enter your actual student ID. You're just entering your secret code name.
Yeah, I was in before. Once I passed the first question, I couldn't move to the next one. It was kind of loading, so I logged out. And I'm trying.
That's because it has to wait for me. That loading was proper. That was okay. It was saying we're waiting for the instructor to go on.
All right.
So you might try shutting the browser window down and trying to log in one more time. I'm sorry for the confusion. There's a little bit of a learning curve. So let's kind of see where folks are at there. Well, I don't mean to leave you behind, Paul. We'll pick you up. Okay. So this is good for me to know. And what's important to realize about my course approach, if you're new to the class, is I deeply respect that people can be working from a variety of points, and I think that there's ways that people can contribute regardless of their Python levels. Being able to ask meaningful questions and looking and learning the basics can often help fill in gaps that other people have. So I want everyone to feel like they have any experience with Python, that they can start in this class. But I also, in the spirit of learning a language, I cannot emphasize enough finding routine times during your week, probably 3 times a week minimum, to say, self, this is Python time, and I'm going to set aside a block of low distraction time and get my book out and my Python.org and hack through some of the problems. I've designed the project specifically to be the kinds of things that you could expand to, you know, capstone level projects if you so desire. So this is good for me to know. Paul, it looks like we got you back in. That's good. Okay, now we're going back to Python. Which of the following is accurate regarding Python's standard library modules? Check all that apply. I kind of spilled this answer earlier. I feel like I jumped the gun.
Don't change your mind. I second guessed myself and missed it.
Oh, yeah, don't change your mind. Okay, and well, I'm just responding to this quick chat. Okay, let's see where we are. So B is definitely correct. Standard library modules include tools, manipulating operating system files, and accessing network resources. C is an interesting one. There is a library for compiling, not compiling, but arranging SQL statements in native Python. You can also inject raw SQL through Python into a database. So someone could argue C with me legitimately. I want to emphasize this because I think it's exciting that we're working with language that can do so much. So everyone jump to python.org. This should be the site that you pull up the moment you sit down to start programming Python. And if you find Stack Overflow on your screen at any time, you should think, self, I probably don't know enough fundamentals if I'm going to Stack Overflow. I find Stack Overflow very interesting for you know, a question like Cliff asked of, is there such a thing of directly executable Python? Stack Overflow is really good for pulling in ideas that aren't a matter of I don't understand how Python works. You know, please give me something to type in to make it do what I want. Oh, I see, Thomas. Sorry, we were confused there. So the way to go, the place to go here is docs, documentation, docs. This is where to go. This is where it all is. So when we say the standard library, what this question was about was this one, library reference. What we mean by the standard library are all of these modules that are they are included in every distribution of Python. So what that means is all you have to do is use your import statement, and you can grab any of these modules. The ones you're probably familiar with so far might be file input, CSV, I think you probably used with file writing, and we'll ask about that next. So the standard library is one go-to place, and then the language reference. So this is where to go if you're in that mode of feeling shaky in Python. This is the page to look up the nitty-gritty of, I can never remember how the for statement works. And so the language reference gives you the kind of the go-to Python stuff, the basics. And the library reference gives you all of the goodies that you can use once you have the language down. So it would be worth your time this week if this site doesn't seem familiar, this is the place to go. You can also explore the Python-C API. This is how you run raw C code. There's an entire API for talking with compiled C modules. So in the spirit of that, let's try our next question, which is about one of the modules. Where are you, so creative? Come back. Here. Okay.
Excuse me.
Yes.
I have a question. I want to circle back to you regarding low-level and high-level language.
Mm-hmm.
I do remember last semester we spoke about binary with zeros and ones, how computer works with. You said it has to do with electricity, with when it's off is 1, and when it's off is 0.
Yes.
So I do remember when I was kind of struggling with the link, so I didn't really pay close attention. I just want to come back and get this straight. So when we talk about that interpreter for Python, it looks like Python is a high level, according to what you said, because it's closer to human language.
Yes.
So saying that, it means it kind of translate human language into computer language. So the computer can read the code. Is that correct?
We would say the interpreter knows how to translate human-friendly Python code into
Computer language.
requests.
Okay.
Yeah.
Okay.
So we could say that computer languages would exist in between each of these layers, but the level of abstraction, we would say, goes up as you move towards human.
Okay.
So the idea of open file, that's a very abstract idea that's translated into very specific hardware requests down at the level of what is the sequence of ones and zeros that I need to give a hard disk drive to tell it, hey, I'm about to ask for a file. And what are the ones and zeros that the hard disk will give back to me to tell me that it's done sending the file? That's the kind of low-level interactions that the operating system and the hardware abstract for you entirely. Yep, good question.
Thank you.
Yep. Okay, so this is, let's jump back to the quiz. So I'm asking you to jump into the CSV module, which I just highlighted. So pull that up on your browser tab, and let's take a minute and orient ourselves a bit to these individual module screens. It is not a stretch to say that this course could be considered kind of a tour through some of the most useful data handling modules in Python. So becoming familiar with a module-specific documentation page is one of the gateway skills for learning more Python on your own. So I want to give you a minute to review this and select what's true about the writer function. And so I'm kind of curious to what extent this is this question even makes sense. And if you're done answering, take a minute and start snaking through that a little bit and see what other objects it links to and that kind of stuff. Okay, about 1 more minute on that. All right, and 10 seconds. All right, let's see how we did. Good, so writer is a function, not a class. Writer cannot be called without at least one argument is true. These are both false. So why are they false? This is an important reminder in Python, which is the way that they write their documentation, which is here's the module. The module exposes a function called writer. If they're in the parentheses, we see the required and optional parameters. So because CSV file does not include a default value, meaning there's no assignment, this would be considered a required argument for writer. Versus dialect, the way to give default values for arguments is to list them with an assignment operation inside the parameter list for the function. So if you don't tell writer what dialect to write CSV stuff in, it'll assume you mean Excel. But if you want a different dialect, then you give it the dialect argument and say dialect equals whatever else what other dialect you want. And you can see linked here are all the different dialects. So becoming, I might even say intimately familiar with these pages is the gateway skill. Because this allows you to start using any of the cool wizard-like functions that Python modules give you, and python.org is where to go, not Stack Overflow and not the clickbait sites. So let's keep going with this a little bit. Still looking at the CSV module, this is a write-in response. List a useful operation that is provided by a writer object and describe when you might use your chosen operation. This is another section of that same page. And this time we're not talking about a function, we're talking about an entire writer object. I want to see what you can cook up. And if you're completely baffled, you can write some snarky thing in there like, stop asking me questions I don't know the answer to.
Hey, Eric. Are you expecting us to have learned about this in the first Python class?
I'm curious. This is
Oh,
me.
okay. I
This
was
is me
going to say,
trying
because
to
I
figure out-
don't think,
This is me figuring out where people are.
I just don't recall ever using this type, the CSV. I don't,
Oh,
I could be
okay.
wrong, but I don't remember.
So you should
there
write
was so
that.
much.
Yeah, I've never
Okay.
for my entire life. This is I'm trying to be more responsive to where students are, and it's hard for me to figure that out unless I actually ask technical questions. So again, this is not a point-based activity. This is a where are we, and I will mull over the next week to figure out what the right level of support is. So I'm gonna let's take another 20 seconds. If you have no idea, you can say I'd love to learn more about the writer object and what I might do with it. Super handy thing, the kind of thing that people dream of in C++ as they write hundreds of lines of code to, to write to files. Okay, let's see. Submit what you got. I don't want to drag this too much. 7, 8. Great. Right row. Good. Teach me, please. You can write the scan the CSV file to find values of interest, such as finding mode, median. I don't remember using this heavy in Python 1. Good. So one of the ways that I designed this question is I wanted you to translate in your brain the idea of an operation to a function. So in object-oriented parlance, a function is, or sorry, a method is a function that is grouped into an object. So Steve asked a good question of, well, what is it like to not have object-oriented design? You won't have groupings where CSV writer is the name of the class that exposes related operations. In a non-object-oriented language, these all live as self-contained functions that could be grouped in a logical way in the same file, or they could be spread across 20 files, depending on how the module was written. So this is handy because when we open a file and we want to write to it, we get a writer object that allows us to write one row at a time, write a group, or write the header row that could then be ingested by a spreadsheet or another tool. So thanks for giving a try on that. Okay. This I think should be somewhat familiar. So the last 3 questions are about basic data structures. Consider the following code snippet. Boy, it's a long one. DAO-dict. What has happened inside the interpreter? Check all that apply. If you have your book handy, you're welcome to look at it.
Hey, Eric, what does instantiated means? Does that mean like created?
Yes, that's the object-oriented term for now there's an object in memory. Thank you for asking.
Yeah.
Do you have any other, is Python your first language, Stephen?
Me?
Yeah.
I took a class in C, and I didn't get it quite so great, but that was like 8 years ago. But yeah, Python is basically my first language.
I also had the experience of my first book was in C, and I thought, boy, this is a whole different thing. So
yeah, they opened up like a command window, and I was like, what? Like, it's not using GUI.
My dad knew C and worked in Shell all day, and we somehow never quite figured out how to work together.
Yeah, my dad, not even. Nah, no.
I think he hated going to work all day, and so coming home and doing more C with me was not a.
Yeah.
Okay, choose your best answer. 10 seconds. If you have no idea, take your best guess. And that's 10. Okay. Oh, okay. So we definitely. So this is the fun thing in Python is we can make, because everything is an object, meaning every variable, even pointers, are objects that point to other objects. Every data structure, list, dictionary, tuple, string, all objects. So A is certainly correct. The B, I was trying to see if you remembered the distinction between lists and dictionaries, which is subtle. It's not so subtle because I named the variable dict. So C is correct. We now have a dictionary with no keys and no values. And our dictionary syntax looks like we could use a review on that. So grab your paper and pen for your brain. Let's do a quick key fundamental object review. So the base objects in Python are tuple. What's the go-to? We'll say string, tuple. These are grouped for an important reason, and I'm not going to tell you because I want to see if anyone remembers. So remember, with Python, strings can be delimited with 1, 2, or 3 quotes. There's no official standard, but the common way to do it is double quotes for standard strings. So I am. What's
immutable?
Pardon?
Immutable?
Yes.
Immutable.
Exactly. Who was that? Paul?
Yes.
Yes, exactly. They're immutable, meaning once we write that object on memory, its value cannot be changed. And that's handy because we can use immutable objects or immutable data structures in dictionaries, which is super cool. Immutable, meaning we cannot change them after we write them. Now, once again, in Python, the immutability is somewhat transparent because if I say string s equals I am string, and then I turn around and assign something else to s, it will happily reassign s to point to my new object. It doesn't say, you overwrote me, I was immutable before, but now I'm gone. It just does it. So what's the identifier for tuples? What's the punctuation?
That's a list. It's a.
That's our friends. Yep. So tuples are cool because they are a comma-separated, ordered sequence of values that don't have to be all the same type, and they often aren't, but they certainly can be. So if we wanted to store the temperature highs for the last 2 days, we could write list in here. And this is cool because we can actually use tuples to key dictionaries and so forth. So we often will ask data structures, give me one of your records as a tuple, and we can then use that as an immutable identifier for dictionaries. So then our immutable, more complex objects would be our list. So we can say list names, and our key punctuation for lists are the square brackets. So lists are ordered sequences. We could store strings in there, separated by commas. Those are my computer names. And then finally our dictionary. And those are our curly braces. And what's the key structure going on in dictionaries?
They have key value pairs.
Exactly. So our keys, we call dictionaries associative containers because they allow us to connect a key and a value. And so in Python, the key value separator is the colon, and that's very common across all sorts of languages. And potentially confusingly, but these are things that we learn to love as programmers, the way to manipulate the keys in dictionaries is to use the square brackets of the list. So these are things that we just have to get used to. So if we wanted to write, like I said in the question on the So Creative, I could add information to the dictionary by saying dict, and then in square brackets, I put in the key. So if I want to store the value of Google stock, I would say, hey, dict, what's going on by the interpreter is it interprets the square brackets to be either a read or a write, depending on whether or not to the right of this is an assignment. So if we have an assignment operator that equals to the right of a square bracket dictionary access, the interpreter knows that what we want to do is create the association between the string goog and the integer 13. And that's done. That's the kind of work that the interpreter does in Python and compilers do in C++. If there's no assignment operator, this is how we extract values from the dictionary. So that's our go-to thing. If there's one thing to practice this week, it's to try to work on your dictionaries for your icon project. So this is, if anything is tattoo worthy in this class, it is this. This would be the helpful thing to have on you at all times. The power of the notation is we can make new objects like we did in question number 6 by just saying, I can get an empty one just by saying dict equals open, closed, curly braces. And that's interpreted by the Python interpreter to mean go to memory, block off a little spot for a dictionary, figure out where it is in memory, ship the reference to that location back, and store it in whatever pointer variable I was asked to work with. So a lot's going on with dow dict equals open close brackets, or open close curlies. Questions on those basic types? Good. These are our best friends. Most lines of Python interact with one of these structures. That's on some level. So that's a good, succinct summary of those. Okay, just 2 more questions. Okay, let's see how your dictionary chops are. So now we know this is a dictionary. We've reviewed key values. If I give you this code snippet, see if you can predict what would come out if you pasted this in. when I spend all morning in C++ and then I come to Python, it's like stepping into another planet. Oh no! Ah, hide! Don't look. You can't see. That's good. And if you already submitted and you're sitting, spin up your Python interpreter and throw that in and see what happens.
So Eric,
Yes.
which data structures
Sorry, you're coming through really quiet.
can you look at the chat?
Still, sorry, you're in the mud. Is that Rob?
Yes.
Yeah, you're. Can you try again? You're in the mud.
Which data structure is similar to an array in C?
Your list. Your list.
Okay.
Yep. A mutable ordered list that can be accessed by index. So that's the array equivalent. Since Rob asked, this is a good example of a time in which Python's decision to make everything an object means that every object, every data type you work with has the overhead of object management, versus an array is kind of the basic ordered sequence of most other languages in which there's no object facilities. I can ask a list for all sorts of things, like reverse it, sort me, give it back to me, and you can ask it to do all sorts of somersaults. That's handy, but it takes overhead from a memory standpoint. So let's see what you think. Take about 20 more seconds. We'll take a break. I see Rachel in the "my brain is fried" mode. This is so nice to have cameras. Boy, I could not get my Python 2s last term to beam anything. I would have a whole screen of just black boxes. So it's really energizing. Okay, let's see what we have. I don't remember this. That's fine. 826. Oh, good. You're on the right track. So this was a good example of a secondary operation. It would not add them all up, but that's a really good guess. So we get a list out. So remember, we've got access on a dictionary to a variety of mechanisms for extracting keys, just values. We can also get the key value pairs out as a tuple, or a list of tuples, excuse me. So I just wanted to see where we are with that. That's good to know, so we can jump into manipulation real soon. So I think there's only one more question, and then we'll take a break. That's true. Here we go. Let's see what you can do. This is still with our data fundamentals. Write a single line of code in Python that creates a list of tuples, each tuple representing an XY coordinate in a Cartesian grid, an XY grid. Name your list coordinates and store the following data as tuples in your list. So now we're dealing with a composite structure, a list of tuples. So just remember what notes we just took, and you should be able to kind of work your way through. So it'd be a very common structure to work with in just about any kind of class.
I did slightly wrong. I accidentally made a list of dictionaries. And I guess it would only be a dictionary of one key and one value.
Glad we're getting some cobwebs dusted off. Okay, just a couple more. Take about 40 more seconds. Okay, hit enter with what you got. Let's see. I want your answers. Hit enter. All right, I'll take that as a, I'm not sure. Okay, so square brackets list, correct.
Hold on 1 second, please.
Oh, yes. Okay, are you ready, Paul?
Yes, I am.
Great. Okay, so we've got a decent range. So remember, a list was always going to have, well, not always, but a way to make a list literal is with square brackets on the outermost pair, and then tuples are the parens, and list elements are always separated by a comma. So this is correct. This would be a dictionary mapping the value of X to 4. So a more complicated structure than we've got. And this would be non-compilable, but you're really close. You were making a list of dictionary-like things. If you had the colon in between those, then we'd map 4 to 11, in this case.
Oh, yeah.
This is a good example of a integer literal that was turned into a string. So in this case, this is legal Python. Don't need the semicolon. That's what I do all day long. So this would be a legal tuple because tuples can be heterogeneous data types. You can have a string, a string, a string, an int, and an int, and an int. You can put that all in a tuple, but it doesn't quite pair our X and Y's together. This would be illegal Python, but the intermediate parts would be legal. This would be a 2-element list. And this would be a legitimate way to store mutable coordinates. If you wanted a mutability on coordinates, you could make a list with the first item being the X and the second item being Y. So that's legitimate. So good review. This is great for me to help plan. What I'm assessed is we're most of us are capable of converting and thinking about our fundamental data types, and I have a feeling that our exercises coming in the next couple of weeks will be probably leveled just right. So without further ado, let's take a break till 55, 19.